All right, I'm going to attempt to record what was happening on Nearpod, but I'm not in Nearpod, so these are just images of the Nearpod slides. So there will be some things that I cannot interact with here, but do my best with uh, what the Nearpod presentation looks like. I did post the Nearpod link onto the classroom, so you can actually go back and look at these slides if you weren't understanding something in class. This slide was different in class. We changed to what does the word math mean to you, but the inverse should mean to you now that you have to undo something. Or if you're talking about order of operation, then you would undo the order of operation in the reverse fashion. So PEMDAS, parentheses, exponents, multiply, divide, add, subtracts becomes subtract, add, divide, multiply, exponents, parentheses. All right, so we'll see what happens with that in a second here. But for this particular scenario here, so what you're doing is, oops, let me undo this here. So this is writing and I don't want it to right now. So let me get on the car here. And get off of that. All right, so you're driving down here in the car. This is jumping around. Try to use the mouse here. So you're driving down here in the car on Paint Branch Drive, and then you would make a right on Stadium Drive, and then a left on Regents Drive. So let me draw some arrows on here. And then right on Fieldhouse Drive. And then as you came up to the student unit building, it would be on your left. And on the next slide, you had to drag rights and lefts into these blank spaces here. As a fill in a blank Nearpod slide. So once you got there, then you want to go back, leave campus from the student unit building. So you turn around, have the student unit building on your right, go down to Fieldhouse Drive and get the Regents Drive here. Then you're going to make a left on Regents Drive, and then a right on the Stadium Drive, and then a left on a Paint Branch Drive, and you'd pass by the parking lot 11B on your right and be exiting campus that way. And then a fill in a blank slide showed up where you had to drag the lefts and rights in the right road there. So if you examine the original directions and return directions that you gave your parents, what do you notice about how the two sets of directions are similar? So let me go ahead and insert text here. So traveling on the same roads, but when exiting campus, the turns are opposite returns made when you entered. Okay, so most of you had a similar answer to that in class, so I think most of you got that. All right, so now let's apply this scenario to a number problem. So your teacher is thinking of mystery number, then they do the following operations to the number in the calculator. They multiply the number by 2, take the result and subtract 5, and then square the result. So the final answer is 49. What's the mystery number? So on the next slide, you're going to answer the poll with what you think the mystery number is. So let's look at the next slide. We'll just write on this slide here. So what you need to do first is, since the last thing we did was square the number, then the first thing we're going to do here is, let me select a pen. The first thing we're going to do, seem to get my tablet to work here, my slate to work here, but so what you're going to do is, let me use the mouse here, 49. You're going to take the square root of that, and that equals 7. So since you squared the result, the first thing you do is take the square root and you get 7. Since you subtracted 5, the inverse of subtracting 5 would be to add 5. And then I get 12. And then the first thing you did was multiply by 2, so the inverse of that would be divide by 2. So you want to do 12 divide by 2, and you get a 6 there. So on the next slide, the mystery number that you should have selected was 6. Excuse me, letter B. So how do we find the mystery number? We did the inverse operations. We take the square root of 49 and get 7. And then 7 plus 5 is 12. And then divide 12 by 2 and you get 6. So this slide right here explains the inverse there. So then we talked about inverse operations. The inverse of addition is subtraction, inverse of multiplication, division, inverse of squaring is the square root, and inverse of cubing is the cube root. And same, it could go the other way around. If these were the original, then the inverse is in the first column. So the inverse is subtraction, addition, and so on. All right, and then you had to match these pairs up here. Can't see them all, but I can't see them, so I can't really. I'll just do this one in the middle here, since I can see this one. So add 5 to the number, multiply the result by -2, and then subtract 1 from the result. So that matches up with this one here. So you go from the last thing you did was subtract 1. So the first thing you're going to do is add 1, and then since you multiply by -2, you're going to do the inverse, divide by -2, and then this one was the first thing you did. So the last thing you do here is subtract 5, the inverse of adding 5. would be subtract 5. So these two match up here. All right, so here, if we wanted to do something and then undo it, so to undo multiplying by 2, you would divide by 2. This is annoying here that my tablet is not working, so you write with the mouse again, divide by 2, and then the inverse of adding 5 would be subtract 5. Okay, when we do things, we do them in order of operation, and then when we undo them, we go the opposite way. So we would start here for the inverse and work your way up in the table. All right, and so this illustrates that. So times 2 and add 5 is do, and then the undo. So the do is this way, and then the undo is the other way. All right. And here on this slide, it shows that. So here's the Pemdas. So if we look at this equation, first we're going to multiply the number by 2 and then add 5. And then we undo it, we subtract 5 and divide by 2. So to write the inverse function, here's f of x. F inverse of x would be, you write down the x, and then the first thing you do to x is subtract 5. And then the next thing you're going to do is divide by 2. So these two are inverse of each other. Here's the original function, f of x, and then the inverse of f of x. Or f inverse of x, you can say it either way. All right, so in the full classes, here's where I left off. So, and this was a draw on it slide. And so if I were to draw on this with my mouse, I would just, so according to PEMDAS, we have to do what's inside the parentheses first. So here you subtract 3 first. Some of you didn't have this right because you're thinking of doing the distributive property and then times 5. And then I'll show you what happens if I do the inverse, do the distributive property first. So to do the inverse, I would divide by 5 and then add 3. So if I want to do the inverse of g of x, what I do is I write down the x first, and then I'm going to do this operation next. So I divide that by 5, and then I'm going to add 3. So the inverse of g of x is x over 5 plus 3. Now, some people were confused because they thought, well, what happens if we do the distributive property first? It kind of changes what the equation looks like. If I did the distributive property first, then I would have this equation originally. It would be like that. And then the do would be times 5. Oops. And then minus 15. So we're going like this here. And then the inverse would be add 15 and divide by 5. Let's see what happens here. should get the same inverse function. So my inverse function for if I did the distributive property first would be this here. It would be G inverse of X, or inverse of G of X, would be, I'd write down the X, add 15, and then divide by 5. Well, if you look at these two functions, they're actually equivalent, because if I divide both of these terms by 5, I have X over 5, and then 15 divided by 5 is 3, and there's a plus sign in between. So these two inverse functions are the same, but the do and undo table would be different if I did the distributive property first. All right, so just remember that they probably picked this one for that reason, is to know that if you have parentheses, you do what's inside the parentheses first. So here to X, I would subtract 3 first, because it's in the parentheses, and then multiply by 5. Some of you had this wrong because you're thinking of this equation right here. Okay, so I'll try to clear that up in class next time, because we ran out of time for me to explain that. All right, so here's the table filled in. Subtract 3, and then multiply by 5, and then the inverse, divide by 5, add 3. So I write down my X, and then do this first, divide by 5, and then this last, add 3. So the original function right here, 5 times X, the quantity X minus 3. The inverse of that would be X divided by 5 plus 3. All right, for this one, fill in the do and undo chart, and then try to write the inverse. So the first thing we would do to X is square it. So I'm going to write that, square it. And then add 7. And then undo would be subtract 7, and then take the square root. So if I were to write the inverse of f of x, so f inverse of x, I'm going to write down my x, right? And then the first thing, so I'm going this way for the do. First step, second step, and then the undo, going this way. So I'm going to do x minus 7, and then take the square root. So the inverse of f of x is square root of x minus 7. Okay, and that's probably the answer key is on the next slide, maybe. Let's go back here. No, let's go here. All right. So do square, add 7, inverse, subtract 7, take the square root. So here's the original, x squared plus 7. The inverse of f of x is square root of x minus 7. Everything under the radical there. All right, so since this is in parentheses here, the first thing you do is add 7. Do the parentheses first, and then square. And then the inverse would be square root, and then subtract 7. So what's different this time? Let's take a look. The difference this time is the parentheses there. So in this one, it would be write down the x, take the square root, and the 7, subtract 7 is not under the radical. So that's the difference here, because the parentheses here kind of change the order of operation. And then when you write the inverse, this 7 is outside the radical. So make sure if you're on a test or quiz, you're writing this or using an equation editor, that this subtract 7 would not be under the radical. And here's the answer key again. So do what's inside the parentheses first, add 7, and then square it, and then the inverse of squaring is take the square root. Inverse of add 7, subtract 7. So I write down my x, and then take the square root of x, and then the last thing I do is subtract 7. So this, once again, this subtract 7 is not under the radical. So the difference between those two, this one had no parentheses around, you squared first. And then the second example, you added 7 first. All right, so fill in the do and undo chart here. So there's more than 2 steps to this one. So the first thing you do is square it. And then the second thing I do is multiply. Maybe I could have just thrown an X there, a little X there. And by -4. And then add 1. So over here, I'm going to subtract 1. Divide by -4. And then square root. So what does that look like? It would look like this here. And I might be able to simplify this a little bit. We'll see. So I write down the x, subtract 1, divide by 4, and then -4. And then finally take the square root. So if I put the negative in the numerator here, it would look like this here. And this is not necessary, but I usually don't like leaving this down here. But so it would be negative x plus 1 over 4. You don't have to do that, but because this is probably a little bit better illustration of just undoing that, undoing what the original was. So let's see what they wrote for an answer here. And they'll let the -4 alone there. So square, multiply by -4, add 1, and then the inverse, subtract 1, divide by -4, square root. So they left its -4 in the denominator. And it'd probably be best to do that so you don't make a sign error when you change both of these. So just leave it like this. Okay, that's it on the slides there. I'm going to go ahead and stop the video here. One thing that you can do if you want to review using the video is, you can stop and start the video at different points and see if you can repeat what I did here, so that would help with your understanding.